It's the last question, 7.4, that I'm really interested in, and you'll see why. Let's go through 7.1 first. So the question, write down the equation of the asymptote of f in the interval 0 to 180. Like I said, when we're doing paper 1, most people, they know the answers to this kind of question. But the problem is the interval. They forget to only look at the interval. So we wanted the equation of the asymptote of f in the interval x runs from 0 to 180. Let me show you what happens here. So we have to focus on only this interval. If you look at everything else, anything else, it is wrong. You need to focus on only this interval. Let me show you what I mean by that. So we can see that between 0 and 80, we have a asymptote at x is equals to 90. So the answer to 7.1, x is equals to 90. You might think it's not a big deal, but I can assure you there's somebody else who took minus 90. Right? They forget to only focus on the interval that is given. But anyway, stories. Let's take a look at 7.2. So 7.2, write down the values of x in the interval. Again, we have an interval which we need to pay attention to. Minus 180 to 0. So minus 180 to 0, where f of x is less than 0. It's less or equals to, rather. Right. So we are looking for where f of x is 0 or negative, essentially, in that interval. So let's take a look. From minus 180 to 90 degrees, we can see that it is greater than 0, right? Well, at minus 180 is equals to, is it defined at minus 180? That's another question we should ask ourselves. Is it defined at minus 180? At minus 180, okay, it is defined. So we don't have an issue there at minus 180. So minus 180 should be part of our solution. Why do I say it should be part of our solution? Because you're looking for parts where f of x is less or equals to 0 in this interval. And that interval includes minus 180. So already we can see that x, oh well, let me change the color there. Already we can see that x is equals to 180 degrees, because when x is equals to 180 degrees, tan of 180 is 0. So that should be minus 180. I think the effect should be the same, really. Yes, it is the same. Tan of 180 is equals to tan of minus 180. So that is part of our solution. But then from minus 180 to, I don't want to say to 90, but to very close to minus 90, we can see that it is greater than 0. So we are not looking for that. That is not part of our solution. But when we go from minus 90 to 0, you can see that it is less than 0. So that should be part of our solution. X is also an element of, do we include minus 90? We don't. Why don't we include minus 90? Because it is not defined. But do we include 0? Let's see. Tan of 0 is equals to 0. It is defined there. So let's include 0 because it is defined at 0. So this is the values of x for which f of x is less or equals to 0. There we go. Okay. So that is 7.2. Let's take a look at 7.3. 7.1. Okay, let's take a look and see what is happening. We're given that g of x is equals to cos of 2x plus 1. The question says write down the period of g. So obviously the period is going to be equals to 360 over 2. Where are we getting the 2? Right here, right? Where it says cos of 2x. Yeah, we divide 360 by that 2. And then the period is going to be 180 degrees. So we have the period. And 7.3.2 on the grid given in the answer book, draw the graph of g of x is equals to cos of 2x plus 1 for the interval, and clearly show the intercepts with the axis as well as the coordinates of the turning points. Okay, so I don't have the grid, obviously, so I'm just going to use this Cartesian plane that is already in front of us here. So let's see how we can use that in order to actually answer this question. So which interval do I want to use? Let me use an interval of 30. Let me use an interval of 30. So from minus 180, I'm going to have minus 150. I'm going to have minus 120, minus 90, minus 60, minus 30, 30, 60, 90, 120, 150. What's the interval again? Minus 180 to 180. So I need all those points. I need to substitute those points into, I need to put that in my calculator and find the corresponding y values. Okay, so cos of 2 multiplied by what? 120 minus 120, everything plus 1. So I'm getting a half. So we have a coordinate here. Oh, not the event. I shall start with minus 180 and not minus 120. What am I doing? So here we get 2, right? So somewhere here we have our first point. And then let me substitute minus 150. 3 over 2, which is 1.5. So somewhere here. I want these dots to be straight. And then let me substitute minus 120. I get a half. So there we go. And then when I substitute 0, oh no, minus 90. Why do I want to substitute 0? Minus 90, I get 0. And then minus 60, I get a half. So there, minus 30, I am getting 1.5. So we are somewhere there. And then 0, I'm expecting 2. Yes, we have 2. I think we can already see the trend. We can already see what is happening here. And then from there, I want to substitute 30. I get 1.5. When I substitute 60, I get a half. When I substitute 90, I get 0. Right. These points are important because I need to show all the intercepts. Okay, and then when I substitute 120, I get half again, 150, that is 1.5, and then lastly 180, I get 2. 180, I get 2. So let me join these points. Let me just use a faint, well lined. Let's see, I want to join these points. So you should have something like this. We can clearly see that the period is 180 here because we have 2 cycles over 360. So that is 7.3.2. Now let's do 7.4. Right, the beautiful question. Clearly show the intercepts with the axis. So you will provide the intercepts there. We can see the intercept. We have 2 minus 90. We have 90. So you will show that there in coordinate form. Yeah, but that is essentially what we need to have. Use the graphs to determine the general solution of 2 cos of cos to the 3x rather minus sine of x is equals to 0. So when I looked at these, I sort of knew that well, the question says use the graphs, but even if the question didn't say use the graphs, I would know that I'm supposed to use the graphs some way somehow. But we don't have the graph of cos of x to the power 3, and so how do we then use the graph to answer this, which looks unrelated to the graphs? Let me show you. So first thing, 2 cos of x to the 3 is equals to sine of x, right? So it became pretty much, straightforward that if I divide both sides by cos of x here, then at least I'm gonna have the graph of tan of x. As you can clearly see, I have tan of x there. So that is tan of x. It's one of the graphs that I have. So I don't want to mingle with it. I don't want to interfere with that. I want to leave that as it is. So how do I then work on these so that it can be equals to my other graph, which is cos of 2x plus 1? I'm like, oh, okay, you know what? Let me take my question paper. Let me go to the back and look at those identities and see if I can come up with something. And then I realized that cos of 2x, right, is equals to 2 cos of squared x minus 1. So take a look at what we have. We have 2 cos of x squared. So clearly 2 cos of x squared is equals to cos of 2x plus 1. And this right here is the graph that we have, right? So we can say but cos of 2x plus 1 is equals to tan of x. So in order to find the general solution using the graphs, we just go into our graphs and looking for values of x for which the two graphs are equals to each other, right? So if we go there, we can see clearly here that we have they are equals to each other at that point there, okay? And then where else are they equals to each other? They are equals to each other at that point. They're equals to each other at that point. Do we have any other point where they are equals to each other? It seems like those are the only points that they're equals to each other. So we need to read off those points. Those points, they look like they are between minus 150 and minus 120, right? So I can just test that. I can say tan of between 150 and 125. So 150 plus 120 rather. That is 270. We divided that by 2. We get 135. Okay, I get minus 135 as the number between minus 150 and minus 120. So let me just substitute it into these two graphs, these two functions, and see what I get. When I substitute minus 135, here I get 1. So let me substitute it here. 2 minus 135. Well, minus 135. I also get 1 here. So x is equals to minus 135 degrees. It's one of the solutions, right? And then here we have 30 and 60. So I'm thinking already, I'm thinking that the point in between is 45. So tan of 45, it's 1. And then cos of 2 multiplied by 45 plus 1 is also 1. So x can also be equals to 45 degrees.